It's spring on a farm in Maryland. Time to sow your crops, and the farmer makes a quiet choice. Plow everything under or just leave those stalks from the last harvest on the ground. And you might think, why would you ever leave that plant matter just sitting out there? Here's a way to think about it. Picture someone crossing the Sahara Desert. Despite the extreme heat, they cover themselves head to toe in loose flowing cloth. And why? Because that covering shields them from the sun, locks in the moisture, and keeps the temperature underneath far more than bare skin ever could. Soil works the same way. Those leftovers, the stems and the stalks, what we call it the crop residue, act as a protective layer for the ground. They block the erosion, hold moisture, cool the soil, and feed the microscopic life that makes farming possible. When farmers make that choice to leave the residue on the field, we call it the conservation tillage. It's good for the land. But here's the problem. How do we actually know if it's happening? Right now, the only reliable way to check is to send someone out there to walk the fields and to survey it with their perception, which you can see examples on the 3 pictures below. And it works, but it's slow, it's expensive, biased, and it can only cover a tiny fraction of the 9 million acres of cropland in the US. And my research asks, what if the satellite could do that instead? I teach a computer to recognize patterns and to estimate how much crop residue is covering the field, just from a satellite image. The challenge is that the affordable, freely available satellites like Landsat, they don't naturally see the residue very well. But the expensive, high-resolution one, those they can. So here's what I did. I trained an AI model to detail the image first, and then I applied the model on the cheap and affordable data. Remember that the farmer making a quiet choice in the spring? Now, instead of one person walking one field, we can track thousands of farms, season after season, from a single regional satellite pass. This matters more than you might expect. Farmer needs this data to prove they are managing their land sustainably. Policymakers need it to design better conservation programs. Scientists need it to measure how much carbon agriculture soils are actually storing. And increasingly, insurance companies are paying attention too, because farms with healthier soils are more resilient to drought, flooding, and crop failure, which changes the math on agriculture risk entirely. By giving all these players the data they need, we can make sure that the quiet choice gets its credit and support that it deserves. Thank you.